Okay, so let's summarize the features that we discussed today. I'll just bring everything here, and I'd like to run this quick summary for you. So, superclass is also known as a base class. In our example, employee is the superclass. A subclass is also known as derived class, that is derived from the base class. And we have two examples of these. Employee part-time, we established this relationship between the superclass and subclass by using keyword extend. So this is superclass, this is subclass. The same thing for employee full-time. This is the subclass and this is the superclass. So the subclass here, such as employee full-time, gets all variables and methods from its superclass. So inheritance allows to inherit all of the components of another class, which is called the superclass. Right? So employee is the superclass, and this is our subclass. Subclass is a specialized version of its superclass. So in our demo, we have two classes that use inheritance, employee full-time and employee part-time. And these two subclasses are specialized versions of the more general superclass employee. And that means that we can build around an existing concept and do additional things based on that original concept which we inherit. When we specify that employee full-time extends an employee, it establishes something that's known as is a relationship. So basically what we're stating here is employee full-time is an employee. And this concept and idea materializes at runtime because, as we already discussed before, when employee full-time object is created in memory, when we instantiate it, the actual superclass instance, the employee part of it, is also instantiated inside this full-time employee. So this is the subclass, and this is the superclass or base class, right? So this is an employee, that's a small box, and the big box is a full-time or part-time in our example. Likewise, we can say that employee part-time is an employee, and it's a different class. It has different implementation here, but it is also extending the employee, and that's the meaning of it. And we say that between the subclass and superclass we have this is a relationship. By the way, notice that the opposite is not correct. You cannot say that employee is a part-time employee or employee is a full-time employee. The opposite is not true. Right, so this is a relationship works in a direction from the superclass, from the subclass to the superclass. And generally speaking, this allows us to add data attributes to the superclass and be able to use them in the subclass. So this is a form of a software reuse. So inheritance definitely allows us to access the means of software use, because both part-time and full-time classes, they both reuse the functionality of their superclass employee. And when we say that our subclasses, like this subclass, are specialized versions of the superclass, it means that we can add new variables and add the code and logic over here on top of what we have already inherited from the superclass. In a superclass such as employee, we can have abstract operations. So the superclass can have abstract operations like this one. We just simply declare this operation abstract. And such operations are undefined. Only the name and the list of attributes is provided, but no method definition. In fact, we use the syntax, we use the semicolon after this declaration of method compute pay. A class with abstract methods becomes abstract class, and this is so we add this keyword to the declaration of our class. It means that the abstract class cannot be instantiated. You cannot write code like new employee. Okay, so for instance, just to highlight this, you cannot instantiate an object of type employee because it's being made abstract. So an abstract class such as employee can be used only as a superclass. Compiler understands that abstract class has unfinished methods like this one, and it's done intentionally. So this is an unfinished concept. The only way this class can be used as a superclass, and every subclass must define the unfinished abstract methods. So if we go to a full-time or part-time employee, we must provide the actual definition of this operation that was originally declared as an abstract in the base class. So when we go to our to the level of our concrete class, the actual class that extends the superclass, we have to provide this definition. So with this in mind, abstract method becomes a concrete method in the subclass. And also we say that classes that are not abstract, we refer to them as concrete classes. And when we say concrete, it means fully implemented, finished, and fully defined, just like this version right here. Also, it is a good practice to use the override annotation to force compiler check whether the concrete method parameters match the abstract method declaration in the superclass. So simply, this is a great idea to add this override, and in both subclasses we would, because we have multiple concrete definitions of the abstract method compute pay, so it's just a good practice to do this. Next, the concept of polymorphism. When we use a reference to a superclass like this employee right here in our run payroll method, and when we're calling an abstract method, a compiler generates the code to direct the call to the appropriate concrete method. And this is called polymorphism. The idea is that the same line of code, this place right here, is capable of calling different methods. And this is also known as dynamic polymorphism, because decision of which method to call is made dynamically at runtime. So we generically say that this type of behavior is dynamic polymorphism. Okay, so in summary, inheritance allows an efficient use of computer memory and simplifies the program logic because polymorphic method calls do not require any if statements or any other structures to make decisions. Everything just works by design. So this is an example of our compute method calls. And the calls are delegated to the correct method implementations, and this is a very desirable approach to organize our classes.